Hi everyone, I am the founder of the Grey Blind Owl. Today we are going to introduce the topic of functions. We will simply show you the types of functions and how to manipulate data on functions. Thus, you will understand why the addresses that we have frequently discussed in our previous two lessons are so important. First of all, why do we need a function that we wrote ourselves from scratch? We need our own functions because not every function we use from libraries can meet our specific needs. This was our first reason. The second reason is that the different purpose algorithms we write in our main function create an incomprehensible code stack. That is why functions are necessary so that we can reduce the load of the main function and edit its display. The third reason is that they allow us to avoid repeating the same code for an algorithm that we will use frequently in the program. Thus, each time we call our function, we can use the block of code that we wrote only once, without rewriting it over and over. In this respect, the use of these structures will place you in a much more professional class in the software developing field. So, what do we need to define a function? The most important part of a function is the type of the function. What will our function give us back? This is the question. If we do not want our function to send us any data, but we want it to change the data that we send, we can use void type. If we want our function to return a data that has a specific type, we can use a type that is the same with our data's type. The second thing that we need to define a function is a name. The last and the third thing is the data that we want our function to use and change them. Usage. Function type, function name, brackets, and the parameters. Data type, variable name, blah blah blah. And the curly brackets. We include our library, hashtag include stdio.h. We create prototypes of our functions in our program. I will explain what a prototype exactly is at the end of the lesson. Okay, we create our main function, integer, main, brackets, and the curly brackets. Now, we create three integer variables, I, j, and result. I is equal to 2 and j is equal to 4. We print I and j before we use swap function. Okay, execute, compile, and run. As you can see, I and j before swap, 2 and 4. Now, we will give I and j to swap function, and I want to see its effect in our main function. So I give my variables addresses to it. I want to see its effect in our main function. Okay, so I give my variables addresses to it. Because main function is completely different function, and swap function is also completely different. Here, integer, main, brackets, and curly brackets. Now, void swap. I use void because I want to change our datas, but I don't want to return any data our main function. Okay, integer main is different function, and void swap is different function. Okay, so they do not know each others. Okay, they do not know each others and their variables. For example, if I define here integer I, this I completely different from this one. Okay, they do not know each other. Okay, I delete this. Now, in this case, if we want to see a change on main functions variable, we have to use their addresses. Okay, if I want to change I and j, if I want to change I and j, I want to see their changes. I have to send their addresses, because these I, for example, these i's address, for example, is equal to 2. If I define here integer I, these i's address, it can be equal to 3. These I and these I are different. Okay, so we have to send its address if I want to see its change. Okay, if I want to see its change. So address of I and address of j, swap function, and semicolon. Swap function wants us to send two variables, one of them I and one of them j. So I sent the addresses of our variables and integer pointer x and integer pointer y, because I send addresses. I send addresses, and we keep the addresses with a pointer. So integer pointer x and integer pointer y. So we put the I value into integer pointer x, and I put the j value integer pointer y. So I define an extra variable in swap function. So these variable cannot be known from this function. So integer temp is equal to star x. We give a reference. We give a reference because we use the addresses. Temp is equal to star x and semicolon. Save the value at address x, and star x is equal to star y. Put y into x. So we put the j value into I value, and star y is equal to temp, and semicolon. Put x into y, because we put the x value into temp before here, and we put the temp value into y value. Now we swapped the I and j values, and we print I and j after we used swap function. As you can see, I and j after swap 4 and 2. Before 2 and 4, after 4 and 2. Okay. Now we will use two different functions that do the same job. They use two different methods. The first one. Multiplication reference. Call by reference method. We send a reference value. So we send an address. We send an address. Like that. This is call by reference method. But we can also use call by value method. We cannot send any address, and we can get a value, only one value, from the other function. This is the call by value method, and this is the call by reference method. So multiplication reference. I will send an integer variable, again integer variable, and I will send a reference value, and I cannot return any value, but result can be changeable. Okay, result can be changeable, because we send the address of our result, and we do not have to return anything because we use reference. Okay, but in this situation we send an integer. Again, we send an integer. We send an integer again. As you can see, we cannot use the call by reference method. We use the call by value method. So we have to return result. Result is equal to I times j and semicolon and return result. And we have to put this value in a value into the integer main function. Like that. Result, this result, and multiplication value ij result call by value method. As you can see, return result. We send result and we get the result. Okay, we sent the result and we got the result. Result is equal to this function because this function is equal to return value. Okay, return value. But in this situation, we do not have to return anything. Call by reference and call by value method. Okay, they do the same job, but they are completely different. Okay, as you can see, 2 times 4 is equal to 8. Multiplication reference I, j, address of result and semicolon, printf, result is equal to the person sign d, result and semicolon. We print the result. As you can see, our result is equal to 8. And the second method, result is equal to multiplication value ij result and semicolon, call by value method, and printf result, the person sign d, result and semicolon. As you can see, result is equal to 8 again. Let's talk about the prototypes. We have to use prototypes if our functions under the integer main function. Okay, we have to use these structures if we have functions under the main function. Okay, because our compiler reads the codes from above to below, like that. 29, 32, 35, 37, 41, like that. But if we do not have any function here, and we do not use any prototypes like that, the compilers read this line. The compilers reads this line, and it does not know anything about this function because we did not mention about this function above. Our compilers does not know this function. It's C integer main. Our variables, our printf function, our swap function. But swap is what? It does not know anything about that. So we have to mention our functions above. For example, void swap, its parameters type, only parameters type. Okay, not name, only parameters type. For example, swap integer pointer x, not x, only integer pointer, and integer pointer again, not y. Okay, we put here these parameters: void swap integer pointer, comma integer pointer, and semicolon. This is a prototype. When we use this, our compiler knows the void function because 27 void swap integer pointer. Okay, there is a function here. Let's go the function. void swap integer x, integer y, okay, integer temp, okay, temp is equal to this, x is equal to this, y is equal to this. This is a function. The compiler knows this function now, and go again. 28 void multiplication reference integer, integer, integer pointer, and semicolon. Now go to the multiplication reference. Okay, void multiplication reference integer I, integer j, integer pointer result. It's interesting. The result is equal to I times j. This is the function. I know that. Go. In 29 integer multiplication value integer, 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 and semicolon. Go to the multiplication value. Multiplication value integer I, integer j, integer result, and result is equal to this, and return result. This is a function, and the compiler knows that again. Now, integer main, integer, blah 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 blah, printf blah 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 blah, and swap address of I and address of j. The compiler knows the swap now, and it can use this function now. So we have to use the prototypes for these operations. Okay, we can also use these functions, all these functions above here, but it seems like confusing. So I do not prefer using these functions above. Okay, that's it. We finish our program, return 0. This week we learned how to define functions, use prototypes, and manipulate data on functions. Next week we will examine the relationship of array and matrices to functions. Thanks for all your effort and patience. See you following lecture. Stay tuned.